Hello and welcome everyone. My name is Peter Robinson and this is the Ethereum Engineering Group Meetup. Today we've got Zaraz who's going to talk about rollups and how Immutable is using rollups. So before you share your slides, Zaraz, can you please introduce yourself?
Sure. So hey everyone, I am Zaraz. I'm a blockchain engineer at Immutable X right now. I've been working in the blockchain space for about 4 years now, having worked at organizations like CryptoSpend, Block8, ASX, and now Immutable X. My work in this time has ranged from protocol level consensus stuff all the way up to application level smart contracts. So if any of these interest you, feel free to connect with me.
All right. Well, so I'm really looking forward to your talk. So please present your slides.
Cool. Let's see if we can get this right. All right, can someone give me the thumbs up that they can see my screen? Cool. All right, well, I've already given a brief introduction of myself, so let's go through the agenda today. So I'll start off with an introduction of Immutable X, our business goals, and the problems we're trying to solve. This will transition into the scaling Ethereum section, where we'll discuss the problems we encounter when trying to build our solution on layer 1 Ethereum, as well as some of the proposed scaling solutions. We'll then go through an application of zero-knowledge proofs by walking through the end-to-end system design at Immutable X and how our implementation improves user experience and enables a modular blockchain architecture. Finally, we'll talk about the future of scaling using zero-knowledge proofs, as well as the hard problems Immutable is trying to solve. So for this format, I'm going to give, I'll send lots of cues for questions. So every few slides, I'll open the floor to questions because I do want to try and make this interactive and try and get people's burning questions out of the way as they come. So I will open the floor up. And when I do, feel free to ask questions. So introducing Immutable X. Let's start with Immutable X as a technology. Our product's goal is simple. Make it easy for games to start giving their players true digital ownership of their in-game assets, achieved through NFTs. Some of our biggest customers include Illuvium, Gods Unchained, and Vivi. Now, we've learned as an organization that traditional game studios don't have blockchain capability. Hiring for and upskilling blockchain talent is hard and expensive. Our technology stack accounts for this by making integration easy through simple REST-based APIs. This means that customers can start minting NFTs through a technology they're familiar with, rather than having to learn about all the trapdoors that exist in traditional Ethereum transactions. For example, having to learn about reverted transactions, finality, gas, front running, all issues they would rather avoid. We also know that L1 gas costs and performance is unacceptable for most studios, which is why Immutable X is built using layer 2 solutions. So I mentioned the idea of true digital ownership through NFTs. What does this even mean? Well, for games, it means that user assets persist independently of the game itself. For example, years ago, I used to play this game, RuneScape. In-game, I would cut wood and I would get logs. What if those logs I got in-game could be used in other games? This is particularly compelling for game studios because they often have the IP for a suite of games, and now they can explore shared assets across different experiences. This also becomes an interesting incentive alignment problem. We have to explore what incentives exist for adopting assets from other games in your game. Something else we've seen is that assets are no longer bound to specific marketplaces. I can take that piece of wood I found in game and sell it through the marketplace experience, which I find most appealing. Ultimately, this gives players better trading experiences. Finally, for games, this also means an off-the-shelf solution for trading. They no longer need to maintain an internal order book and write complex settlement logic. They can turn any asset into a tradable asset. Although Immutable X targets games, these benefits aren't bound to games. The ability to make any asset tradable in a free market is valuable, even when applied to use cases like ticketing and carbon trading. Now, I'm going to pause there for a moment. Any questions about what I've discussed so far? Cool. I'll move on then. Now you've understood a bit about what we do at Immutable. But our solution doesn't work on Ethereum layer 1 because of scalability issues. Let's dive into that. Now, a key component of our offering is minting of NFTs. Let's say we were built on layer 1. Firstly, minting can cost anywhere from $1 to $30, depending on Ethereum network congestion and ETH prices. Already, this variance is a big barrier for most studios. Then, of course, performance. At 12 seconds per block and a maximum of 30 million gas per block, you're looking at about 62 mints per second if you assume 40,000 gas per mint. And 62 mints per second, for many use cases, this just isn't sufficient. We've minted over 500 million NFTs for our partners' use cases. If we tried to do this on layer 1, assuming an ETH price of $1,500 US, we could have paid anywhere up to $600 million for 50 million NFTs. And I can tell you that we haven't paid anywhere near that much. So now we know Ethereum layer 1 has its issues and isn't right for our customers. How do we scale? There are many scaling solutions that have been proposed for Ethereum. Some focused on scaling layer 1 through solutions like sharding, but the majority of emphasis has been placed on layer 2 solutions. In the layer 2 space, we've seen solutions like state channels, sidechains, and Plasma come and go. But there are two solutions that are the focus of the Ethereum community, and that's optimistic rollups and zero-knowledge rollups. So zero-knowledge rollups rely on validity proofs, but optimistic rollups came first because they're simpler to implement. The EVM architecture as it is able to support the generation of fraud proofs, which are used in optimistic rollups, which is the mechanism used to identify invalid state transitions. But it has major trade-offs, like the need to wait for a challenge period, often set to a week. For Immutable X, if we had chosen optimistic rollups as our solution approach, it would mean that users could be waiting up to 1 week to withdraw their funds to layer 1, which is an unacceptable UX for us. The more emergent and arguably more exciting solution is zero-knowledge proofs, which is the technology we focus on at Immutable X. Zero-knowledge proofs allow us to completely inherit the security of layer 1 Ethereum. So what does inheriting the security of layer 1 Ethereum even mean? Inheriting the security basically means you don't need your own consensus mechanism on layer 2 to prevent transactions from being removed and reorganized arbitrarily. Anytime you see a consensus mechanism on a ZK layer 2, it's usually just for censorship resistance. You may have heard in the news all of these organizations building ZK-based solutions and all the hype around ZK EVMs. So the reason we're hearing about it now is because making validity proofs of EVM-based transactions is hard. Building validity proofs relies on complex maths involving arithmetization, finite fields, and much, much more. The EVM architecture is not designed to work under the constraints of things like finite fields. But many people smarter than me have worked very hard to make it possible. So you may also have noticed in the slide the term validium next to zero-knowledge rollup, sorry. This is because relatively recent nomenclature suggests that the term rollup is a data availability concept, but we'll get into that a bit later. But before I move on, I'm going to open the floor up to questions again.
I've got a question. Oh, hold it. I can see that Naveen has a question. Naveen, please go ahead.
Oh, sorry.
No, okay.
I think I forgot to mute my mic. Sorry about that.
Oh, not to worry. All right. Does anyone have a question? Because I've got a question. All right. So my question was, so we've got Starkware, ZK Sync, Consensus, Polygon, and Scroll as ZK technologies. Are all ZK technologies born equal? Are they all the same, or are there differences?
Good question. I feel like you would know the answer to this already.
Or is this a future slide thing?
Good question. Good question. So we will talk a bit more about the differences between different ZK technologies, but I will say there are various trade-offs that different ZK technologies will make, and some of the levers you can pull. So say, for example, one of the levers you can pull is how easy is it to write smart contracts? Do you want to make it super easy, as in close to Ethereum, or do you want to make it pretty hard, as in very different? Another lever you can pull is how difficult is it to actually implement the technology and versus easy to implement. So there's a few levers, but I will talk about this a bit more in the future.
Great, thank you.
Cool, I'll move on then. So a bit about the Ethereum, the ecosystem landscape. If you're interested in getting a holistic view of the layer 2 landscape, I'd highly recommend L2B, where you get deeper insights into the trade-offs, security mechanisms, and escape hatches of various layer 2 protocols. They're unbiased as far as I'm aware, and you can get a view of protocols without the rose-tinted glasses. So now let's actually talk about zero-knowledge proof systems at a high level firstly. So the high-level idea behind zero-knowledge proof systems is that there exist two entities. One is the prover, and one is the verifier. The prover generates a proof that a particular state transition is valid and provides that proof to the verifier, who is able to quickly verify that it is correct. Let's apply that to the Ethereum context. So it means on layer 2, there exists at least one honest prover who is willing to generate a proof for a batch of transactions. The proof is then sent to a smart contract on layer 1, which has a function that will validate that the proof is valid. There are several properties that are important to note, which play into why we even use this approach. Firstly, proof verification is computationally simpler than just executing Ethereum smart contract transactions. If the L1 verifier needed to execute each transaction to verify a valid state transition, you might as well just send transactions to L1, barring storage costs. We also note that the proof of the state transition is separate from the state transition itself. This is where the zero knowledge comes in, i.e., the verifier has zero knowledge about the state transition itself, but it can validate that the state transition was correct. So we had a bit of a mouthful there. Any questions?
So yeah, I have a question.
Go for it.
When you talk about the state and what's posted to layer 1 and so on, is it the state on the layer 2 chain, or so what is the state actually?
Yep. So usually we refer to the state as any of the differences in the storage state that occurs based on transactions done on layer 2. So one of the optimizations that some layer 2s that use zero knowledge technologies do is they just post the state difference between what happened on layer 1 and what happened on layer 2. So one scenario where this optimization is realized is, let's say, for example, we have a simple smart contract where you're incrementing a counter. That counter is going 1, 2, 3, 4 across each one a separate transaction. The state difference you post on layer 1 could just be, hey, before it was 0, now it's 6. You don't have to post each of the 1, 2, 3, 4, 5, 6 that resulted from each of the transactions. So you only have to post the state difference. So that's what I mean by the actual state. Any other questions before we move on?
Oh, yeah, I have one question.
Yep.
So the example you gave is a simpler example, but let's say that there are 10,000 transactions to be executed. Okay.
Yep.
So there are 10,000 transition states.
Yep.
So in that case, the verifying proof will take much time, right?
So the verifying proof, the beauty of the way the zero knowledge system works is that the verification doesn't actually scale linearly with the number of transactions or the number of state transitions. It actually scales to a logarithmic function, so it's much cheaper to actually verify the transactions. So even if we get lots of state transitions and lots of transactions, verification is still relatively much cheaper than actually executing them sequentially. Does that make sense? Can I?
Yeah. Thank you.
Cool. If there's no other questions, we can move on to the next slide. Cool. Now let's go through an end-to-end flow of how we apply zero knowledge proofs at Immutable X. So let's say Bob, the gamer, wants to transfer one of his digital assets, a game card perhaps, to Alice. He executes a transfer request through an in-game experience. He signs the request, and then the request is then sent to the Immutable X backend servers. Now, our backend system maintains the current view of the world. For example, we know the current balances of accounts and the tokens that exist. Our system will validate the request is a valid state transition, checking that Bob actually owns the card that he signed and that he has signed correctly. If it passes our system check, we synchronously return a success response to the user. If our system determines that it's an invalid signature or an invalid state transition, we synchronously return an error. To Bob, we're presenting instant finality. And this puts an interesting requirement on our end. Our system needs to have an accurate representation of the state of the world. What happens if our system fails to do this, and where do the proofs come in? So asynchronously, what our system does is it periodically sends batches of transactions to the Starkware StarkX service. This is done asynchronously. The StarkX service is managed by Starkware, an organization that has developed ZK technology. They run this service known as StarkX. StarkX is an application-specific rollup. What this means is that the set of valid state transitions is limited, i.e. not Turing complete. In our case, valid operations include things like minting, transfers, and settlement. This has the benefit of being better optimized for proof generation. So once the StarkX service gets this batch of transactions, it does two things. It'll send the batch of transactions to the sharp prover for proof generation. Recall that in our zero-knowledge proof system, there exists a prover and a verifier. In our current setup, Starkware runs this prover, which will generate the proof, and send it to the contract which lives on Ethereum layer 1. The next thing StarkX does is it sends the state transition details to the data availability committee. Recall that with zero-knowledge proofs, we can separate the proof of a valid state transition from the actual state transition itself. In this case, we send the proof to layer 1, but where does the state transition itself go? We introduce the term data availability as a reference to where the state transition details live. Obviously, Immutable X has those details, but what if Immutable X goes bust? Well, if we go bust, what users need to be able to do is recreate the view of the world that Immutable X has, i.e. be able to view which assets they have and view the state of the world. Recreating this worldview requires getting the state transitions from the data availability committee, who will provide that data. We could also post the state transition data to Ethereum layer 1, providing even stronger decentralization guarantees in the case none of the data availability committee are cooperative. But this has costs associated with it. However, these costs will dramatically reduce with the introduction of EIP 4844, which is proto-dank sharding. EIP 4844 is part of Ethereum's roadmap to support rollups as a scaling solution. Once this is ready, it may lead us to revisit the need for a data availability committee. Back to the proofs. We can even see directly on Etherscan the smart contract which verifies the proofs and the function verify proof being invoked every few hours. This particular verifier is shared across multiple applications. Immutable X StarkX has been one of them. Despite that, in the past year, the total value in fees paid is about $340,000 US. Compared to the 600 million we could have been facing on layer 1, this number is much easier to swallow. I'll pause there now for a second before we move on. Any questions about what I've said so far?
Excuse me, what are exactly the data availability committee? Are they a set of nodes, or what's that?
Yep. So they're not ETH nodes in the sense. Really, what they, if we think about it as a service, really all they're running is an API to some degree, and they serve information about the data from the state transitions. They're not in any way related at an ETH node or anything.
Okay. So is that the Immutable X running those committee nodes?
There's multiple parties that are involved in that committee. Immutable X is one of them, but there are other entities as well. I think Starkware is one of them, and there's a few other. I think there's 6 or 7 in total. I don't have the exact names off the top of my head, though.
Cool, thank you.
But I have a question.
Yep.
What happens if the Immutable X service goes down? I assume then for the period that the service is down, basically the system cannot be operated. Is that correct?
Yep, good question. So these are, of course, we want to provide the strongest guarantees we can to users. So one of the things that users can actually do is they can force withdraw their assets from layer 2. And this means they can, if they have assets that live on Immutable X in the layer 2 system, they're able to eject their assets forcibly without any interaction with Immutable through a layer 1 smart contract. And that's one of the benefits of actually using a ZK-based layer 2 system, is that users have these sort of guarantees in the scenario that the sequencer on layer 2 is no longer responsive.
So I have a question related to the Starkware prover. So you mentioned that you were taking advantage, I guess, of, let's say, the form of the transactions, minting, or I can't remember the other one. So you've got a subset, basically, of the EVM instructions that you have to encode and arithmetize. So that enables you to optimize the prover, the time to generate the proof, I guess. Yeah.
So we only have a subset of operations that we can actually do.
Right. So have you customized, or did Starkware customize their proof generator for you, or did you do it yourself?
They did the customization for us, that optimization there. Interestingly, you can even find the Cairo smart contracts, which implement things like the transfer. They're open source, things like the transfer and the mint operations and settlement state transitions that we take advantage of. Cool. Now I want to talk a bit about the modular blockchain architecture, which is almost always a topic that's discussed in the context of zero-knowledge layer 2s. Now we have a full picture of our end-to-end system architecture. I want to talk about one of the implicit benefits we're getting by using a layer 2 solution like zero-knowledge proofs. Ethereum on its own is a monolith. It's responsible for processing transactions, which are each sequentially executed in the EVM. It provides data availability as it acts as a permanent storage of data. It also has its own consensus mechanism, proof of stake. It also acts as a settlement layer for applications that don't live on Ethereum layer 1. For example, it allows you to post Merkle roots, validity proofs, state hashes, whatever you'd like, and hence acts as a settlement layer. What the community is finding is that this has caused problems for Ethereum, especially from a governance perspective. Changes to Ethereum are heavily critiqued, and every change needs to be rightfully scrutinized. But this slows innovation. By moving transaction execution off-chain to layer 2s, we've actually taken the first steps towards a more modular architecture. This allows us to explore innovation in transaction execution without all of the governance issues of Ethereum layer 1. For example, some rollups have been exploring optimistic parallel execution of transactions or exploring new data models, changes that improve execution throughput, but also changes that can't easily be applied to layer 1 directly due to legacy decisions. For Immutable X, the modular architecture has enabled by zero-knowledge proofs has allowed us to both have transaction execution and data availability away from Ethereum layer 1, saving us the gas costs of both on-chain storage and transaction execution. The modular architecture doesn't just apply to Ethereum. It can apply to any blockchain. That's the innovation of zero-knowledge proofs, the ability to offload transaction execution and data availability. Immutable X is heavily committed to the Ethereum ecosystem, but hypothetically, we could post our zero-knowledge proofs to a different consensus and settlement layer, such as Solana or Sui, as long as these settlement layers allow you to write smart contracts which can verify a zero-knowledge proof. Any questions about the modular blockchain architecture?
Sure, I've got one. You mentioned it can be executed on any sort of, I suppose, EVM-like chain.
Yep.
Why do you choose Ethereum out of all the options? Because it's not the cheapest one.
Yeah, definitely. So when deciding on your base chain, you're really deciding on what's the strongest guarantee you have for your transaction. If, for example, we posted to another chain such as Solana, where the strongest guarantees we have for our transactions being final to some degree is the guarantees that we trust Solana. In this case, Solana, I won't speak to, Solana specifically, but Ethereum has a proven track record. It's been around for many, many years. It has an active developer ecosystem. People are heavily involved. It's always improving. And I think in terms of smart, like blockchains that can actually, on which you can actually write arbitrary smart contracts, Ethereum is really the front runner in this space.
Fair enough.
is Immutable X actually building that capability outside of Ethereum, or is that too private information?
We're heavily committed to the Ethereum ecosystem. Cool. Let's move on to some interesting UX topics. So now you may have noticed something about the way we model our system. We actually present instant finality to users for transactions like minting and transfers, even though those transactions might not be bundled into a proof till much later. How are we able to confidently tell the user that their transaction is guaranteed to be successful when it comes time to proving? We know on layer 1, we can't assume that if we send a transaction to a node, that will be included in the block. Nor can we assume that the transaction output will be what we expect due to things like front running. These aren't a concern in our system because our system acts as a sequencer, enforcing a global ordering. Of course, this does mean that we lose some censorship resistance, but this is a trade-off customers have largely been comfortable with. More in the topic of UX. So Immutable X offers free minting and transfers of NFTs. The cost of mints and transfers to us is non-zero, i.e., there is still a cost to us. But recall that with StarkX, we have bounds on the set of possible state transitions, for example, minting, transfers, and settlements. This means that because we know the upper bound of cost for things like mints and transfers, we can subsidize them and instead take margins on things like trades. This is necessary for games as a use case in particular, because users don't want to have the experience where even to start getting game assets, they have to pay. That's the sort of gaming onboarding friction we don't need. We want players to acknowledge their value of their assets before they have to pay anything out of pocket. If you were just starting a game for the first time and you had to pay fees before you've even properly understood the game, you'd probably drop right there. That's why our approach is to take margins on trades instead, which is when the value of their assets is acknowledged in the free market. Pause there. Questions? All right, I'll move on then. Oh, we have one?
I don't think I hear there's an explanation on how do you achieve the instant finality.
Yep. So let's to explain instant finality, let's understand why we can't have instant finality on Ethereum. And then as a counterexample, we'll show you why we can have instant finality. So one of the reasons we can't have instant finality on Ethereum is because when we send a transaction, we don't actually know where in a block it's going to be included. For example, it could be included arbitrarily and in an arbitrary position in a block. And one of those positions could mean the transaction's reverted. We also don't know if it's even going to be included in a block because for example, what if the actual validators decide not to include a transaction in a particular block? That means that when we actually send a transaction to Ethereum, we don't know if it's going to be included until it's actually been included in a block and it's actually been finalized, which is not really instant finality. So what we determined from that, the requirement to present instant finality is we need to have a global sequencer which has full knowledge of the sequence of transactions. Because when you have knowledge of the sequence of transactions, you are able to tell whether a transaction will actually complete or won't complete, because you know it's not going to be reorganized into a different position and hence fail. So that's really the requirement that you need. And hence we have that, we fulfill that requirement, and hence we're able to present instant finality.
Yeah, so am I right then in a big part of it is that the games developers, so the people running the games that the users are using, uses the Immutable X like platform, and they fully trust the sequencer in Immutable X to sequence it, not say reorder the transactions, because because normally with a rollup, you'd have a ZK rollup, you'd wait for the proof to be posted before you would say it's final, but you can say instant finality if you trust the sequencer. So that's part of it too, isn't it?
So I would say that we're not able to do invalid state transitions. So we can't do things like, we even if we wanted to, we can't do things like transfer assets from your account to someone else's because we don't have the ability to sign on your behalf. We don't have those things. Those are invariants which are really enforced as part of the proof verification process as well, and the proving process. So we can't do things like that. Even if we did have the ability to reorder transactions arbitrarily, with the knowledge that the set of state transitions that's possible is limited, you have to really wonder what's the worst that we could do. For example, we know that in a Uniswap scenario, there's liquidity pools and you can front run and then you can get, the slippage fees. But in the scenario that you front run someone else buying an asset before you, I guess maybe that could be one of the worst case scenarios, but really we can't steal your assets from you and we can't take it away. So there are still strong guarantees that you have, but yes, we could do things like censor your transactions potentially and not include it.
Yeah, so you could censor, which is not including, or as you said, make invalid. So I don't know, say Chris wants to buy a sword, you're selling a sword, and then I could jump in and somehow or other convince the sequencer to put that in first, so then he doesn't have the money to buy your sword because he's bought my sword. All right, that would require the sequencer to be corrupted, and if we trust the sequencer, then we're good. Anyway, so sorry.
Yeah. No, great question.
I've got a question related to what you just mentioned, the gas fees and so on. So minting is free, transfer is free, and you said it's because we can get an upper bound of the gas cost. What if the gas cost changes in the future for some operation opcodes in the EVM? Is it still true, or will you have maybe to upgrade your contracts or the fees as well?
It shouldn't, if the EVM opcodes change for in layer 1, it shouldn't change anything on our perspective unless that increases the cost of proof verification. In that case, if that is a possibility, we may need to look at it again and see if our economics work out. So yes, that could be something we need to watch out for. Cool. Let's move. Yep.
So can ZK proof solve front running problem?
Can ZK proof solve front running problem? I guess, well, we would probably need to elaborate that on a bit more, in the sense that you can do a state transition with some degree of privacy. We would have to think about what sort of guarantees, what sort of system we operate in for us to be able to say if it solves front running. I would say if we were living in the system that we are right now, no, it doesn't solve front running. But we would have to explore what sort of system zero knowledge proofs are applied to be able to say whether it actually solves that problem.
Okay. And another question is, so this layer 2 platform is providing the proof of the transaction to layer 1. What if layer 1 rejects that proof? What happens in that case?
Yeah, that's a good question. So for us, the only scenarios in which case the layer 1 rejects that transaction is if our system state has been corrupted and we've somehow sent bad transactions to the prover, and the prover has generated a false proof and sent it to layer 1. In our case, the StarkNet system is able to catch these invalid state transitions, which would be rejected by layer 1 before it's sent to the layer 1 smart contract. In the case that does happen, which is very rarely, rarely occurs because, we might have some, it occurs very rarely. But in that case, we do have to reconcile it on our end to make sure that it is a valid state transition. So it does pass the L1 proof verification. Because if it doesn't, that's a business ending event for us. If we're not even posting proofs to L1 and we're just living in a la land.
Thank you.
I've got a question about the sequencer. I wonder if it's just a single server in the cloud, or it's a cluster of servers.
So it is run as a distributed system in the cloud.
Okay, so in that case, I just try to understand the architecture. So if users submit a transaction to Immutable X, so it will choose a server randomly, and that server will do the sequencing and then broadcasting the sequencing to other servers, or how does that work?
Yeah, good question. So our API is actually just, think of it as like one logical server, but it's actually distributed. So AWS has many features which allow us to make things look like they're a single server, but under the hood, it's many distributed servers. So we don't need to worry about having our own consensus mechanism to reconcile between servers. That's all abstracted by many cloud services for us.
Okay, okay, I got it. I think it's just like a traditional cluster of servers, something like that.
Yeah.
Cool.
All right, I got a quick question about your slide, if that's okay.
Yep, go for it.
Transfers are free. Trades have commission on.
Yep.
So transfers, basically bartering is free, but trading for money carries a commission.
Well, I think we have to see what the guarantees are here. So bartering in the sense is not free, because to execute on a barter, you need an atomic transaction that moves one asset to another person. And in the case of a transfer, you couldn't do that atomic action. If you both trusted each other and you're like, hey, you send it to me, I'll send it to you. Sure, you might be able to do that. But if you don't trust them, you wouldn't want to do a barter in the sense of, transferring to each other without the atomicity guarantee.
Yeah, I suppose it depends on the features of the network. I mean, if you had something like a contract where you could do that, but obviously you probably don't because of a limited set of features in the provided by the StarkNet. Okay, cool.
Yep, and we'll definitely talk a bit more about the feature set in a few of the follow-up slides as well. All right, let's move on. Cool. Now, the future of zero-knowledge technology, which is now we're getting to the exciting stuff. And so there's a lot of technological innovation happening in this space. As I mentioned, Immutable X uses StarkX today, which we can consider to be an application-specific rollup. This has its limitations as it can't write arbitrary smart contracts, as that would mean arbitrary state transitions, which the StarkX system is not able to generate proof for at this stage. Breakthroughs in technology, though, now mean that systems can have general purpose applications being built, which can then you can actually create proofs for arbitrary state transitions, i.e. any smart contract. Many approaches are being taken on this front, attempting to handle the difficult tech challenges of grappling with zero-knowledge proofs. For example, StarkNet has built their own smart contract language for which proof generation is quick, but you lose the ability to write EVM smart contracts. Others like Consensus is building a ZK VM, and Polygon is also building their own general purpose ZK EVM, aiming to get higher compatibility with the EVM, i.e. writing smart contracts in Solidity. But they have trade-offs. For example, the time it takes to actually generate proofs is much longer. Of course, these are all levers people play around with, and it's up to them to decide what is best suited for their purposes. For example, some businesses which are very nascent in the space and don't have an existing tech stack with their own smart contracts might think, hey, I'm comfortable writing Cairo smart contracts because I don't have my own existing contracts that I've built out. But if you already have Solidity smart contracts you might have built out for Ethereum layer 1, you might look at some more of the ZK VMs and think that's more of an appropriate solution for you. So now we know that today what Immutable X at a high level looks like today. Users come to our global order book, they can sell and trade assets, and we use StarkX as a settlement system to post proofs to Ethereum. Something we've discussed. But now we're exploring a future where there exists multiple layer 2s, and the futures is multi-chain. This creates exciting opportunities as it means greater access to liquidity for gamers trading their assets. What that means is that now there's potential for users to be able to trade their assets, not just with other assets on StarkX, but potentially with other assets that live on other chains. And of course, there's many problems that come along with that as well. This doesn't come without its challenges. There's many things we need to consider. One of those things is, for example, transaction finality. Do customers want layer 1 finality, which means waiting until the proof is submitted to layer 1? Or can we give them other guarantees with faster finality, but with slightly less guarantees? These are interesting levers we can play around with as well. Privacy regulation is another one we saw with, I guess, the whole Tornado Cash debacle last year, which is also a system built using zero-knowledge technology. Performance is a big one. Although many zero-knowledge layer 2s boast high performance potential, realized performance is still low due to growing pains. Transaction atomicity is also an interesting problem we've been looking at. This comes in the domain of cross-chain zero-knowledge bridges and how we could give users greater access to liquidity in that multi-chain environment, which is also an interesting problem that comes around as well. Finally, L2 sequencer decentralization. I think this is one that we've touched on as well. What does, how can we give stronger guarantees to customers that they won't be censored on layer 2, while still also maintaining a great user experience? Lots of work to be done ahead. All of these are problems that we are thinking about at Immutable. But that does also conclude my slides. So I'm going to open the floor to the last round of questions.
Can we get a copy of that the document you've been showing?
I think Peter will share the slides in the link.
Yeah, I will. So there'll be so this will be uploaded as a YouTube video sometime, I don't know, later today probably. And in the description of the YouTube video will be a link to these slides. I think everyone's already asked all the questions.
No, I have a question actually, Peter.
Frank.
No, but in terms of performance, for instance, and let's say resources that you need to generate the proofs for your subset of the EVM, I would say, language. Can you give us some sort of ranges? What kind of machines you need? What's the configuration in terms of memory, CPU? How long does it take? What's the size of the proof?
Yeah. I don't remember the numbers off the top of my head, but I recall seeing some of the configurations that were needed for some of these zero-knowledge systems. And we're looking, in terms of RAM alone, you need up to a terabyte of RAM. CPU, I don't remember the exact number, but yes, the numbers are, then you do need quite a hefty machine. But also the thing is, it's quite intense. But I would also note that it's not like Ethereum layer 1 where we need to make it as accessible as possible to be able to run a prover. The guarantees are very much different as to who needs to be able to run a prover. Because if you have at least one prover in a system, that's good enough of a guarantee. You don't need to have many people running it.
So I have another question if nobody has any other question. Shall I go ahead, Peter? Or?
I can see that there's one from...
Okay, so I'll leave the floor.
No. Just don't go too far away, Frank. So Ikla said that, could you talk about the audits that have been done or will be done? Also, is there any bug bounty program?
I believe we do have a bug bounty program on one of those platforms for bug bounties. I don't recall it off the top of my head, but I know someone on our side does. And regarding the audits, so the main part of the system that is audited is the Starkware system, which is the actual proof generation and the verification. So that's all been looked at as already. So we know that we can't do invalid state transitions from that perspective.
All right, why don't we have your next question, Frank, and then we've got one from Julius in the chat.
Okay, thank you. So yeah, it's related to actually security or reliability. What are the assumptions about what are the trusted components in your system?
Right. Yep. Good question. So the trusted component is, for example, the server that we run, which allows users to send transactions and then we post them into batches. The trust assumption is that we will not censor your transactions. There is no need for trust that we will mutate. You don't need to trust us in the assumption that we will do something that malicious on this, do an invalid state transition, because we can't do that, because that's enforced by the zero-knowledge system. But the trust assumption is we won't censor you.
So, but the zero-knowledge system is also a trusted component.
Yep, as a software component, if there were issues in that would be a trusted component as well. Yep.
Well, that's you assume that it's trusted, right?
Well, we assume that it functions as it's supposed to, as a software piece.
So then that's related to the previous question. Has it been audited, or did you have some, I don't know, some verification on it and so on? And related to what you mentioned as well in the talk, you say, oh, we chose Ethereum because it's Somehow it's been around for a long time and so on. So there are other, let's say, smart contracts languages that provide more security or safety in terms of formal verification and so on. So that could be also an argument in favor of other technologies.
Yeah, I mean, definitely. I think there's definitely arguments back and forth. I don't think anyone would win in those arguments. I've personally been around many smart contracting languages. I've seen Daml, I've seen Solidity, I've seen Accord project. I looked at Sui's smart contract language as well. So anyone can debate for either of these. But I don't think that's necessarily for me to make the judgment call there. But I think definitely from the Starkware software perspective, my understanding is that it has all been audited. I think, yeah, that's my understanding.
All right. So Julius said, I'm wondering what will happen if the proof that was posted to Ethereum, so that transaction, if that was reordered. So yeah, if that transaction was reordered and essentially dropped out, what would happen?
Yeah. So similar to most other transactions with Ethereum layer 1, any off-chain system will generally just wait for some period of time and then assume a level of finality.
Yeah. And I guess if, say, you posted it and it didn't have enough gas, so it was eventually dropped out of the transaction pool, I guess you repost it maybe in a transaction that was prepared to pay more fees or something, maybe. Yeah,
because the proof submission to layer 1 is not as frequent, where we have to worry about transactions potentially being coming out of order, because this proof submission, if you saw the Etherscan slide, most systems are doing it once every hour or something, which is plenty of time for us to get a strong finality guarantee.
Yeah.
With that proof submission, is that sent by Immutable, or is that sent through by StarkX?
That's sent by StarkX.
Thanks.
I've got a question about that last slide about the Starkware, like the second layer 2 that's going to be on. Does that mean that it's going to open up for developers to use the full suite of StarkNet products or services? Because one of the criticisms of Immutable is StarkX is very limited to what the developers can use, which Ethereum smart contract versions they can use. Is this like a solution to that problem, creating another set of tools that they can build, another set of smart contracts they can access?
Yeah, good question. This is a known problem to us, and this is one of the biggest pain points of anyone building on the Immutable X system, which is one of the things we're actually actively trying to solve. I can't say too much more about how we're solving that, but I will say that it is something we're aware of and solving.
Any time frame allowed to give on that?
I don't want to say anything that might get me in trouble.
Oh, go on. We live on the wild side, so
Yeah. All right. Look, I think that was a great talk, and I think you've answered must be about 20 questions, maybe 30. So that's really good. So thank you for coming on and delivering this talk. Yeah.
No problem.
In the next, if you can flip to the thank you. If you flip to the next slide, okay, brilliant. So I'll quickly walk through. So we've got some scheduled talks. There are some unscheduled talks that aren't in this list as well that we're working on. So next week, there's a talk on blockchain accounting. So Musa Badin's done a PhD, and this is essentially his research work. We've got Roberto and Tan Hai. So Roberto's one of the people who's been asking questions here, and he's going to be talking about the DVT, which is related to Ethereum 2 Beacon Chain, and so the formal verification of that. Babu is going to come on and talk about his idea around MEV. And then we've got Barnaby from Ethereum Foundation is going to talk about the proposer builder separation 2 weeks after that. So at the moment, I'm in discussions with 2 people around 2 separate talks that are likely to happen in April and May. And one of them is about the mathematical properties of automatic market makers. So they've analyzed and done research on what are the common properties that all of them end up actually supporting, and why is that important? And then separately, there's another person who has analyzed the space and has a few ideas on how AMMs could work better. And, they've got some quite novel ideas. So two AMM talks coming up, and I will write that at Solidity Assembler talk sometime. And for those who asked, so is it possible in Assembler to jump from one function to another function without a function call via the Assembler? The answer is yes. I've worked out how to do it. So anyway, I'll post that code at some point.
I have a few questions which I have posted in the chat, please.
Sorry, what did you say?
I have a few questions which I have posted in the chat. You may have to scroll
You've
up.
got quite a few. Oh, sorry, I missed those questions. All right. There are quite a few here. So, Zoraz, I'm not sure if you can see the chat. So, what will be ZKP use case in traditional investment bank which don't use blockchain? Ooh.
Yeah, sorry. So I can't actually see the chat. I've been looking for the box, but so you're going to have to dictate them for me.
Yeah.
That's fine.
Zero knowledge proof in traditional banking. I can take that one if you like, but please go for it.
No, I think if you have a strong answer here, go for it.
Yeah. The Monetary Authority of Singapore have used zero knowledge proofs for interbank settlement. So at the end of a trading day, you might have one bank owes another bank, say $1 billion, and owes another bank, $600 million, but those other banks might owe them a whole heap of money. And so rather than them trying, they don't send each other money back and forth. What they do is they normally talk to a central bank. But to get rid of that centralization, what you can do is you can use zero knowledge proofs to prove how much you each owe each other without actually saying what your balance is, and then do settlement in that way. So that's certainly a traditional banking use case of zero knowledge proofs that I've heard of. Yeah. The second question was, are there any internships or maybe hackathon opportunities at Immutable?
We are planning, to my understanding, hackathons coming up in the future. Regarding internships, I would recommend having a look at the careers page at Immutable, see if anything's available there. But yeah, I think definitely the best option is to go to the Immutable website, and I'm sure there's a subscribe link or something to stay up to date with this sort of stuff. So that's what I would recommend.
Could you please, is there a certification you could do, say, to be in zero knowledge proofs?
Interesting one. Look, I have a personal stance on this, which is that in the blockchain space, I don't trust certifications as much as actual experience, just because things change so much, and a 3-year-old certification isn't going to mean very much to me. So I would say, look, it's better to have practical experience and have real hands-on stuff, and real maybe GitHub projects or whatever to demonstrate real capability, than trying to do some certification through some pre-programmed path someone's made for you. But that's my personal stance.
I agree with you. And I think if you really want to get into this space of rollups, there are a few different areas that, you could follow. And one of them is around circuit design. So these zero knowledge proofs invariably require circuits. And I can tell you there's a lot of people who are out there scouring the planet for people who know how to write zero knowledge proof circuits. So if you decided that you were going to become a zero knowledge proof circuit writer and started writing some circuits just to teach yourself, and watch some YouTube videos and such like, I think that could be a good way of getting a very high paying job. Which wouldn't be a certification. And that then goes to, sorry, go ahead.
Oh, no, sorry. I was just going to recommend a resource, but you can go for it.
Yeah. I was going to say the next question is actually, it's sort of similar. It's what's the underlying mass required to master zero knowledge proofs? And it's a range of things, isn't it? And in fact, there's a talk from, I know you've just said don't trust stuff that's 3 years old, but that Roberto did about 3 or 4 years ago. So Roberto, so look for a talk on the Ethereum Engineering Group Meetup YouTube channel, where Roberto did a talk on ZK snarks and that whole area of mathematics and how you went from essentially code to an elliptic curve pairing. And so that was a great talk to talk about the maths. But yeah, I don't know, Zoraz, do you have any other thoughts?
Yeah, I think one of the resources I personally used, zkhack.dev is a good one. They have a lot of stuff there. But yeah, no, in terms of the math, a lot of it, it brings me back to my uni days where you'll see a lot of matrix multiplication, like linear algebra. A lot of these things will start to crop up again. So if you have a strong, preferably university education of those things, that could be good. If you don't falter. I'm sure there's online resources available.
Yeah. And is Rust a good programming language for zero knowledge proofs?
Tricky one. I can't say what sort of libraries exist in the Rust ecosystem. I know that JavaScript is definitely a strong one because they have things like StarkJS, which allow you to start interacting with zero knowledge proofs and building them through an easy to use wrapper interface without having to get too deep into the maths. But I can't say if those same libraries exist in Rust.
Yeah, I believe that I think ZK Sync and I think Consensus of ZK EVM is a sequencer or is written in Rust, I think. So they're probably the libraries out there. But yeah, I don't know. And that is the end of those questions. Have I missed anyone else's questions that were in chat? Okay, I think I've waited long enough this time. Can you go to the next slide, please? There's one last slide. Okay, brilliant. All right, so if you are watching this right now, this is on YouTube, and just go to the Ethereum Engineering Group YouTube channel. Will be posted later today. There's a Slack workspace and you can use that link to go there and ask questions and meet people, discuss this talk. If you're watching this on YouTube, please join the meetup and you can ask the tricky questions that you have live. Sometimes there is example code with the talks, and that often is on that GitHub repo. And also Frank runs a formal methods reading group. So if you're interested in formal methods, join the Slack workspace and go to the FM reading group channel. And with that, I'm going to go stop share. All right. So thank you again for doing a fabulous talk. That was great. And yeah, I think we've all learnt lots. So that was really helpful. So thank you.
I'm glad you guys enjoyed it and hope you learned something new. Thanks for having me, Peter.
Thanks so much, Zoraz. Excellent talk again.
Thank you.
Thank you.
All right.
Thanks.
Talk to everyone later. Bye.
Thank you. Bye.